We are going to analyze what is the binomial expansion, so we know that the binomial expansion is that one that we can see as term A plus term B to the power of term n. So a quick review: in the regular binomial expansion, you can find n plus 1 terms. What this means is that the power that the whole parenthesis plus 1 is the number of terms that your answer must give you. To count the terms in the expansion, you can identify them as they are separated by plus or minus sign. So, for example, if we have a minus b to the power of 4, we are going to have 4 plus signs or 2 negative signs and 2 positive signs. Because whenever we have a plus b, then all of the signs are going to be positive. But if we have a minus b, as we can see in the example, there is going to be first negative, then positive, so minus, plus, minus, plus. And there are 4 plus 1 terms identified by the 4 terms. And lastly, we know that the term independent of x, or the constant term, is the same as x equals to 0. So later on we're going to know how this is going to affect our answers, but we need to have this clear. So x to the power of 0. Now a quick relationship that we can find is that one of the Pascal's triangle and binomial's coefficient. What is that? So as we can see in the first picture, Pascal's triangle is that one of the pyramid where we find first 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. How does this pyramid work? Well, as we can see in here, so all of the corners are going to have a 1, all of these corners are going to have a 1. As we go down the pyramid, we can analyze something, and it's the fact that the number in the middle is the addition of the number of the sides. So in here, as we only have one number, there's nothing. And in here is where we start. So 1 plus 1 gives us 2, then 1 plus 2 gives us 3, 2 plus 1 gives us 3. Here 1 plus 3 gives us 4, 3 plus 3 gives us 6, 3 plus 1 gives us 4. 1 plus 4 gives us 5, 4 plus 6 gives us 10, and well, the same thing for the rest of the pyramid. And then we have the binomial's coefficients pyramid. Something in the Pascal's triangle are these numbers in here. So for what we can use the Pascal's triangle? So whenever we have a binomial expansion that its power is not so big, because we imagine doing the whole pyramid, for example, if the power was 20. So if the power is 2, 3, 4, 5, even 6, you can do the pyramid to find the coefficient, well, the number that is going to go with the variables of the expansion. In the binomial's coefficient, we have the same thing, but here it's we can see these brackets, so it's the same thing as the pyramid. So for example, 0 to 0 is the same thing as 1, 1 to 0 and 1 to 1 is the same as 1 and 1, 2 to 0 is the same as 1, 2 to 1 is the same as 2, and 2 to 2 is the same as 1. And in the last one, 3 to 0 is the same as 1, 3 to 1 is the same as 3, 3 to 2 is the same as 3, and 3 to 3 is the same as 1. So that's the relationship between both of these pyramids, that they will give us the same number, so we can use either of these pyramids if we are only going to work for small powers. Now there's something we need to take into account, and it's what we call NCR, or in other words, N choose R. This is to choose different objects from N, meaning it is a selection. We can also know this as CR to the power of N, C in brackets N, R, or binomial of NR. The formula is N factorial divided R factorial times N minus R factorial. And this is just a general rule that it's very important that we know, and is the fact that NC0 is equal to 1 and NC1 is equal to N. So in many times whenever so for example, I'm going to do here a quick example. Whenever you see this, so later on we're going to find out what is this with the TR terms. Whenever you see something like this, you can use these formulas. So this number these numbers, this number will be n and this number will be r. So we just could simply replace these values with the formula and then we will get the answer for doing that bracket, because that's not a division, neither a multiplication, that is an NCR. So it will be R chooses 2. And there can also be given the formula of NC n minus R to solve an equation, but the process will be the same as NCR. This is due to the fact that when we choose R out of n objects, it's the same as choosing n minus R out of n objects. So what is this? Because the formula of NC n minus R is this one. But if we start to simplify it, so we multiply this, then we get this, then we multiply this, and we get this. And if you can remember from the previous slide, this was the formula for NCR. So it will give us the same answer, but it's easier to use this formula because you will only need to do a smaller process. Now there's another term that you are also going to discover if you're working with binomial expansion, is we also have an NPR or n permute R that is defined as arrangement. So the formula for NPR is NPR equals to n factorial minus n minus r factorial. So this is as well very important for binomial expansion. It's not so common among the examples, but it as well is very important that you know it. And to get this in the calculator, so for example, if you want to find in the calculator NPR, as well as if you want to find NCR, you will only need to use the key option in your calculator if you have a graphing calculator, and then after clicking option you go to prob, that's a probability, and then you're going to find either NPR or NCR, and then you'll only have to put in the numbers. And now so we are going to analyze or learn about a little of the tiered terms formula. So to find the specific term in a binomial expansion, we can use the tiered terms formula. So we have 3 different formulas for this example. The first one is TR plus 1 equals to n over r, x to the power of r, y, n minus r. So you should be asking yourself, so what does this mean? So again, if the example or the question is going to give you something like this. Now with these terms you already know that x is this x, y is this y, and n is this n as well. It can be positive or negative. It would only affect this term. And in order to find r, that's what we're going to explain in the following slide. Well, we also have this formula that is TR plus 1 equals n over r, x n minus r, or y to the power of r. This depends on if this number is easier than this one, or if n is a very big number, or if we already know what is r. So it just depends on which one you believe it's easier for you. And the last one is TR equals to n over r minus 1, x to the power of r minus 1, and y to the power of n minus r minus 1. So later on we're going to find out why it's easier to use either of these 2 formulas rather than to use this one. So here we can consider an example. So for example, let's say the question gives you consider the expansion of x plus 2 to the power of 11, and it tells you find the term containing x squared. So you could use it using Pascal's triangle, but you will need to write 1, 1, 1, 1, 2, 2, and so on, but that will take you a lot of time. So you say to yourself that there must be an easier method, and that's why we have the TR terms formula. So it would just be using this. So we already know that n is, this value would be 11. We don't know what is r. And we know that a equals to x, and we know that b equals to positive 2. So taking that into account, we only need to find what is the value of r. And how do we do it? we replace, so we would have x to the power of n, that is 11 minus r, and we have 2 to the power of r. And as they are telling you that we need to find x, that of x only, we're going to say that 11 minus r, because we're going to take the only one that its coefficient is x. 11 minus r equals to 2. Why 2? Because this one here, this is giving us the number of 2. So then we just simplify. 11 minus 2 equals to r, so r equals to 9. And if you already see the example, we have here that r equals to 9, 11 over 9, x to the power of 2, because we already did that. 11 minus r is 9, and 2 to the power of 9, if you do this in the calculator, so we already know that this will be to put in the calculator. 11 chooses 9, and this will give us a number, and this will give us 55. Then you multiply it to 2 to the power of 9, and it will give us this question. And if you know, give you an identifying here, it's giving us the term containing x to the power of 2. Now some tips that you must know. It is easier to use the formula of tr plus 1 rather than tr, because it's faster to remember and to do calculations with. So believe me, you're going to be less complicated with tr plus 1. It does not matter if it is used the expression of n over r or n over r minus 1, since it is going to give the same number. So you do not must worry about these two formulas that I showed you at the beginning. It's just the same thing. And lastly, the term minus n to the power of r can also be written as minus 1 to the power of r times n to the power of r, or minus n to the power of n minus r can also be written as minus 1 to the power of n minus r times n to the power of r. How we will do this? Because we want to separate the negative sign from the value of n. So sometimes when you can see that the expansion is a little bit tricky, you can do this and it will help you a lot. Lastly, regarding everything that we already see, we can deduce that a trinomial expansion is written as x plus y plus theta to the power of n, but well, that was all.